This is an automatic height adjustable brush. What do you need it for? In my case, Tool 0 is a V6, where the brush has to be at a different height than for Tool 1, a volcano. The brush can now be automatically lowered to clean the longer volcano and automatically raised again to clean the shorter V6. Let's start with the assembly of the height adjustable brush first. For this, I'm cutting a stepper motor with an integrated lead screw to 130mm length. The end of the lead screw has to be chamfered properly so that the threaded nut can be easily screwed onto the spindle. I cut 2 spindles because I'm building 2 adjustable brushes. For the whole brush unit just shown, you need a motor for about $15, simple brushes for about $1 and 100mm long linear rail clones for about $10. Also a PTFE sheet 1mm thick for about $5 and a few screws. Post-process the printed parts, add M3 and M4 threads to the printed parts. I cool the tab with alcohol. It evaporates from the printed parts without leaving any residue. Then mount the linear rail on the printed part, so the carriage can no longer get off the rail. Mount the motor and pick the corresponding threaded nut. Gentle blows with a hammer ensure the necessary fit in the printed part. The brush holder can then be mounted on the linear rail with the lead screw. At last the brush. It is fixed with a screw. Here I am cutting out a small piece of PTFE that can serve as a wiper. This piece of PTFE is mounted to the brush with the same spacer bolts as from the electronic parts. Since I want to mount a height adjustable brush on both sides of the Toolchanger, here's the assembly of the mirrored version in time-lapse. I bought these set of brushes for $1 at eBay. One is brass, one is steel, and one has nylon bristles. I find that the nylon bristles are just the right hardness for what I like. And you can use a simple saw to cut the brush head to length and mount it on the holder. And here's the second PTFE wiper mounted to the brush. Okay, this is what the two height adjustable brushes look like. Pretty neat. Did you know that half of the time I spend on tutorials is spent on cleaning and tidying up and getting rid of the mess? I just want to mention that. Your Toolchanger is probably jealous now, huh? Underneath the motor of the brush attaches a small self-printed cable duct, which brings the motor cable from the motor along the side panel to the back of the printer to the duct. This cable duct can simply be clicked to the motor from below. On the back you can see where the cable will come out of the duct. Since the height adjustable brush can also be mounted adjustable in height itself, I mount it in the middle position for a start. Now I can drill a hole in the electronics panel, exactly in the center of said cable duct, to feed the cable through. I drill a hole of 8 mm diameter here. A tip from me I learned the hard way: if you remove the self-printed cable duct before drilling, you prevent that you ruin the printed part with the drill when drilling through the panel. As you can see now, one can adjust the brush in every height, but the cable with its feed through is still always inside of the cable duct. I tighten the brush permanently in this position and remove the cable duct to pull the actual cable through. This motor cable came with an E3D Hamera. To get it through the hole in the back of the printer, I have to remove the connector and jacket from the cable. To do this, you can carefully lift the barbs with not a screwdriver, better pick a sharp knife, and then pull the pin out. Remove the additional isolation and the wires can now be put through the duct. After that, put the wires through the hole you just drilled. Continue to pull the wires through the channel and plug the connector into the motor in advance. Now you can put the loose wires back into the plug. The polarity of the individual wires does not matter, as long as green and black and red and blue stay together. On the duct, all motor connections are already occupied, And on the ducts, 3 motors are already plugged in. 2 slots are still free. If you count the connections 0, 1, 2, 3, 4, 5, 6, 7, 8, then the motor cable of the brush is plugged into slot 8. In config.g, I add almost at the end, directly before the G10 offsets, all necessary parameters to control the brush. These parameters are M584, the socket 8 to the A-axis, M574, the end stops for axis A as stall detection, M350 microstepping, M92 steps per millimeter for axis A, M205 the jerk, M203 the maximum speed, M201 acceleration, M906 the motor current in milliamps, M208 the axis minimum, and M208 again axis maximum. Depending on how you have built your brush, the length of the axis may differ. Also the other parameters. You can either just copy these changes into config.g on your duct or upload the whole local file. An important note: in one of the last firmware updates it happened that the command M584 cannot be used after certain other commands. Therefore I remove the command here and add it above in the existing M584 for the other axis. Here you can see the parameter as A8. After all these changes in the configuration, you should restart the printer. Of course, a new axis must also be homed. To do so, I uploaded a file that is ready to use. home.a.g is a simple copy of the homing file for X and Y with slightly modified parameters. All files shown here I'll put in the corresponding article to this video for download. Additionally, the home.a.g file must be referenced in the homeall.g file. For this, I simply copy an already existing command and change it to the A-axis. Now you can see the new axis in the dashboard, and when you click on its home button, the brush should move down to the end position. If the axis moves upward when homing, which is wrong, then on the back simply turn the plug of the motor cable. But attention, switch off the power or de-energize the drivers beforehand with the command M84. If you did, the axis should move downwards now. If all axes are homed via the button Home All, the A-axis should also home at the end. Let's move on to setting the brush height for individual tools. To do this, Move the brush all the way down and position a tool near the brush, in this case tool 0. Then slowly move the brush up until the bristles just touch the silicon sock. In my case, that's at 33 mm of the A-axis. In the tool change macro pre0.g, the z-axis is lowered 10 mm to prevent the hot end from diving into the print bed. This is a good place to move the A-axis to 33 mm as well. Repeat the same process for tool 1 with the volcano hot end. The brush is moved down first and then moved closer to the hot end in short steps. The determined value of 24 mm is entered into the macro file pre1.g of the volcano tool. The A-axis can be moved with a normal G1 command as any other axis. Was it 23 or 24? Not sure. Let's have a look. 24. Okay. Back to pre1.g and change it to 824. Okay, save. If tool 0 is called, the brush automatically adjusts to the height of 33 mm. And when switching to the volcano tool, the brush automatically moves to the height of 24 mm. I copy this change for the first V6 into the files pre2.g and pre3.g for tool 2 and tool 3, since they also have a V6. Let's move on to priming the actual tool. To do this, I have adjusted the coordinates to the right brush in advance. Watch out! If you use the default coordinates of the provided file from E3D, your toolhead may be driven into its limits and crash. I activate the call of the file prime.g in all tool post macros. Now, when a tool is picked up, the brush moves to the correct height and the prime macro is executed. Since the tool is cold here, no filament is extruded. Okay, this looks alright. Let's check the volcano. Okay, the volcano hot end is a little close to the brush. I will change the position down to 23 mm. that looks better. Just to make sure, let's pick tool 2 and tool 3. Again, there is no material extruded because the tools are cold. I feel like the brush is still a little too high on all the V6 tools, and I go to set the brush half a millimeter lower on all of these 3 tools. Okay, now a quick pass with all 4 tools again to make sure of the height. Now the purge macro. Again, it is important that all coordinates in the macro are adjusted to the right brush. As with the priming macro, the purging script must be activated in all 4 tool change macros. This way, if tool 0 is called, the nozzle will be primed first, like this, and then purge before being put away, like this. The same is automatically activated for the other tools. But as you can see, this is all happening rather slowly and not perfect at all. But it is working in general already. To further optimize the macros, I adjust the extrusion parameters a bit and remove the long pause in the purge macro. Let's have a look at these changes. Yes, that's much better. As you can see, the priming and purge macros have not the same effect on the V6 and the Volcano. I'll fix this problem with a special macro for the Volcano in a moment. First, let's do a test run of all 4 heated tools with the prime and purge macro adjusted. As you can see, there is still a lot of oozing, especially after priming. So from now on, the settings made are very individual and depend on your tools. I will briefly show you how to optimize the prime and purge macro and adapt them to different tools, such as the Volcano. However, you can spend whole days with this kind of optimization, so my changes here should only be exemplary. To be able to test changes efficiently, I copy the contents of the prime macro into a user macro inside of another test folder. The advantage is that I can call a user macro much faster one after another, and therefore the test runs faster. So first test run. Let's have a look. Okay, hardly any material comes out at priming. Oh, and it starts oozing immediately at the end of it. So let me change the return movement across the brush first to save us some time. Someone wise probably once said, less wiping is sometimes more. I also increased the speed of the slow extrusion. Okay, another test run. Okay, the filament already extrudes a little bit faster and is not wiped as long as before. Let's increase the speed of the 10mm extrusion a bit more. Okay, another test run. Yeah, now a lot of filament extrudes. Oh, but there still seems to be too much pressure for the retract after. What should I do? I think I increased the slow extrusion by 1mm to the sum of 2mm to relieve some pressure. Okay, have a look. Yeah, nice flow. Okay, probably hard to see, but I like the retraction for the time being. I copy these changes from the user macro to the actual prime macro. To adapt the prime macro for the Volcano hot end as well, I create a new file named primevolcano.g. To start with, I copy the original prime macro into it, but increase the retract to 1mm because of its big nozzle, and I do change the call for the Volcano prime macro in its Toolchanger macro, tpost1.g. When tool 1 is picked up, the Volcano Prime macro is executed now. You could just see that no material came out of the nozzle at all when priming. Let's do another test. Just again. Okay, this time a little more, but not enough. So let me increase the first extrusion from 10 to 15 millimeters. Okay, that looked better, though there's some material oozing at the end and we needed a little higher retraction. Probably 1 millimeter. Yeah, it's starting to look good. Just one more to make sure. Perfect. I transfer these changes to the Volcano Prime macro and test the tool change just once more. Okay, a retract of 0.5 millimeter more might improve the oozing just a bit more. Yes, that's it. Okay, with all of this, you are able to implement your own adjustable brush. With an axis like this on the side, you got even more options. Maybe mount the pebble wiper to it instead of this ugly brush. Or mount a microscope to it to use for offset alignment, or even a touch probe for the assemble toolhead. And all of this stuff is coming soon in a tutorial like this. If you liked this video, please give it a thumbs up. And if you don't want to miss upcoming videos with interesting content, make sure to hit the subscribe button. Also, if you would like to support me and receive exclusive benefits in exchange, check out my Patreon, where all my designs are available for download too. In case you got any questions to this video, leave a comment, I read them all. Thank you for watching and I'll see you next time.